Let's continue to talk about the rest of the string processing procedure in Advanced 32. So we will see the U case for uppercase and the compare. So the first one for the uppercase procedure. So you will convert a string to all uppercase character. You return no value. Yeah, because they will just simply updated all the letter from the string to the uppercases. So on the other hand, if they're already uppercases, we do nothing. But if they are lowercase, we will convert to the uppercase. And on the other hand, if you are not a lowercase letter, we also remain the same as well. So that's why here we have a hello as the string. So then you have the first one already is uppercase. So we were expecting the rest of that, the E, L, L, O, they will all convert to the uppercase. So after you done, the string should be look like this. So to run the string U case, you will have the invoke string U case. And also, right, we need to pass in our parameter using ADDR for my string. So how should we do that? Right, I already give you the hint here, right? So I want you to think about from the ASCII table. Here is the lowercase. Here is uppercase. So how should we do that? (6141). Actually, this one means the hexadecimal number. So that's, if you remember, right? So we say actually the hexadecimal number, the uppercase and the lowercase, actually they are only different in 61 minus 41 equal to what? But this one is actually the hex. So actually 61 minus 41 is 20, right? But if that's a hexadecimal, that's being 16 times 2. Right, actually their difference in decimal is 32. So if you remember before, so for the lowercase and uppercase, they only different with the 32 number. 32 means the 2 to the 5th power. So that's why here 2 to the 5th power is 32, right? So actually for the uppercase and lowercase, the difference is the 6th digit in the binary, right? So that's why here for the A, actually lowercase a is bigger. So for the lowercase a want to convert to the uppercase a, we need to clear the 6th bit in the binary system. So then they will from A to lowercase a to uppercase a. Did you remember how to clear only one bit? Clear only one bit, we need to use AND or OR. Right, so clear specific one bit, we need to use the AND with 0, right? So then we remain all other things the same. Very good, so that's how we'll do that. Actually, this one is the important thing, how we will convert our lowercase to uppercase. So here, specific for the lowercase, so then we have, right, we have our source array. So that we will move that to the ESI. So from here, if we find that's the any character we want to change, so from this ESI, we need to end the 110. See, this 0 actually is the 6th bit. So the 6th bit, we need to be clear, so that's why we can have the lowercase being uppercase. So that's how we will convert the lowercase to uppercase, right? But the most important thing, we need to find where they are. So that's why here you will have a loop. So every time we just have the ESI move to AL. So we compare if AL equal to 0. Yeah, if equal to 0, then we finish. So then we go to the L3, we finish. But if not, we need to see, right, so this one actually we have the range. Okay, so this range is to make sure they are between lowercase and uppercase, right? Because we only care A to Z in lowercase. Other character, we have nothing to change. So that's why if they are below A or above A, we all need to skip. So we increment ESI, we come back to the L1. So then here, right, if not, that's the number we need to convert. So that's afterward we update our P string. So then for these cases, we use the AL to save the value and ESI to have the array location. So that's why we use this EAX and ESI. So that's for the string uppercase. So the same thing, we always need to ask, do you have any other way to implement this procedure? If not, do you know how to implement the string lowercase procedure? Right, so you just do the opposite, right? So earlier you cleared the 6 digit, now you need to set the 6 digit. So then of course you can try to change that. Pause the video anytime, so complete to see what you can make that better. So then we will go over to the next procedure. Let's compare two procedures. So since we need to do the compare, we have two procedures. So that's why we have the prototype, we have string 1 and string 2. We both passing the byte array location. And also we want you to set the carry flag and 0 flag accordingly. So one thing is, because we need to compare, right? So we need to know which one is bigger. So if they are the same, of course, 0 flag equal to 0. So that's why 0 flag is set. So then we know they are the same. But if the carry flag is set, that means the string 1 is smaller. And on the other hand, if both carry flag and the 0 flag not set is clear, that means the string 1 is bigger. So that's we will according to the status flag to check which one is bigger. So how should we compare two strings? Right, so again, this one, since we have two strings to do, right? So just like copy, so we can consider, can we use the COMSC repeatedly? But when we want to use COMSC repeatedly, so how should we set the loop? Right, so earlier when we do the copy, we can use the COMSC. That's because we have the string 1 copy over to string 2. So we know our ECX is the length for string 1 plus 1. But now this time we need to be careful. Unless you specify string 1 and string 2, in this case for compare, they has to be the same size. That's why we can use the COMSC. Right, so if you remember, last week on Tuesday when we talk about COMSC, we do have one example we compare two strings, but we assume these two strings they has to be the same size. But now string 1, string 2, we cannot require they are the same size. On the other hand is string 1, if we have any of them, they have the no character at first, then we just finish. So that's why here the COMSC we couldn't do that because they need to have ESI and EDI, they have the same size. So that's why we can repeat to do that. Unless you can try to see is you can have the length at the beginning for string 1 and string 2. So then you see if they are the same, use the COMSC. But that's all maybe too complicated. So that's why here we cannot use the COMSC because we need to check either string 1 or string 2, they hit the no character. Actually, we just finish. So that's why here we will see the the string compare. We will have string 1 and string 2. We're still using the ESI and EDI, but this ESI EDI is not really for the COMSC. We just simply to using the comp. So every time when we reach that location, so then we will have here, because they both are memory location, so that's why we need to move the ESI to the AL, EDI to the DL. So that's why we use this EAX and EDX. So that's why here, you see, every time before we compare, we need to check if AL equal to 0, okay? If not, right, we continue. If not equal, we continue to increment one by one. Otherwise, we should finish. So that's why here you will see when we comp AL equal to 0. If not 0, we continue. So that's L2. So then the same thing, we need to compare the second string. If the second string is not 0, right, I continue here. But any of that, I need to return. I just simply return. So that's why here only L2 is important. L2 is compare if I have more. That means they both are not 0. So then here we increment ESI and EDI first. So then we can compare only AL and DL. That's why you see here, when you do the comp, this one, when you do the compare, that's here AL and DL, they set the carry flag and the 0 flag. So that's why here, if they are equal, we continue, go back to L1. Otherwise, if they are not equal, we can just right away finish. So that's why if equal, we go back to L1. If not equal, actually they just continue for the L3, we return. And also when we return, because jump, they don't update anything. So when we come back, our status flag also already been set. So if they are equal, of course we continue. If they are not equal, so then you will have your 0 flag or carry flag set. But remember, even they are equal, they go back to L1, right? So we will check if L1, if AL or DL, they are equal to 0. So that's why actually they will just finish to the return. So if they are exactly the same for these two strings, we just come back to finish the L3. So that's the string compare implementation. Yeah, we always need to ask this question. Do you have any other way to implement the string compare procedure? Or this one, is the status flag being updated correctly? Okay, so make sure you have that over check again. So then you can run this example.